Good morning or good afternoon. Today we are going to move on and talk about Unit 3, Lesson 20, which is inequalities. We've already talked about how we can compare using greater than or less than. Now we're going to add to it a little bit, and we're going to be using greater than or equal to and less than and equal to as well. So, start off. It says a grocery store is giving a reusable bag to every person who donates more than $5 to charity. Let X equal the amount that a person donates. Use words and symbols to solve all the following problems about this situation. So, on the first question, A, it says Ella donates $5.50. Will she get a bag? Explain how you know. Well, did she donate more than $5? If she did, which $5.50 is more, we would say yes, she will get a bag. And then how do we know? Because $5.50 is more than 5. So B says Daniel donates $5. Will he get a bag? And explain how you know. Well, is $5 more than $5? No, it's not. Okay, because $5 is equal to $5, not more than $5. So if we look at C, it says Courtney donates $1.25. Will she get a bag? And explain how you know. Well, is $1.25 more than 5? No, it's not. $1.25 is less than $5. So D, name two other amounts people could contribute and get a bag. So we need to put anything that's above $5. So we could put $6, we could put $10, you could put $5.01, because all of those are above $5. They are all greater than 5. So E says to get a bag, are the amounts greater or less than $5? Well, obviously we've been talking about that. It would be greater than. So F says use the symbols greater than or less than to show X is greater than 5. So here's our X. It is bigger than, remember these are the teeth, the big alligators eating the bigger number, $5. So G says explain how you know when any person should receive a bag. So it would be when X, because this is the amount that people are donating, the amount donated is greater than $5. Okay, so it says a sentence such as X is greater than 5 is called an inequality. So inequality, that's going to be our vocab word. On the previous page, you identified values for X that make X is greater than 5 true, like $5.50 or 10. But there are too many possible values for X to be counted. Unlike the equations we've seen that have one solution, an inequality may have infinitely many solutions. That means that there can be any number of solutions that would fit to make an inequality true. So, here are some symbols and words to describe an inequality. So obviously we have the one that we're used to, which is greater than. You can see more than, greater than is above. And an example is X is greater than 5. Then we have our less than, which we've used before. Less than is below. And we have the example at the bottom of X is below 5. And you can see the sign there. Then we have our two newer ones to us, which is greater than or equal to and less than and equal to. So whenever you see greater than or equal to, it might say it's greater than or equal to. It might say it is at least it is no less than, or it is a minimum of. For less than, you might see is less than or equal to, is at most, is no more than, is no greater than, or the maximum of. Okay, that means it would include the number it is talking about. So when we look down here at x is greater than or equal to 5, that means 5 and anything bigger. Here, when we say x is less than or equal to 5, that would mean 5 and anything less than 5. So number 1 says, explain the difference between an equation like x equals 5 and an inequality like x is greater than or equal to 5. So in an equation, so we have x equals 5, there is only one solution. Which means that x can only be that one number. Okay? And inequalities have many solutions. So for example, x is greater than or equal to 5. It can be 5, it can be 6, it can be 7, it can go on for any number above 5. So let's talk about how to write and solve inequalities. The problem says when the temperature drops below 15 degrees Celsius in a building, the furnace turns on. At what temperature will the heater turn on? Write an inequality to represent the situation and graph the solution on a number line. So for the first model, it says you can use words and symbols to represent the problem. So it tells us let x equals the temperature in the building, so that would be whatever temperature it is. It says when x is less than 15. So just like on the previous page, when it says less than, we're using the less than sign, and it would be x is less than 15 when the heater turns on. Okay, the next one, we can graph it. We can graph the inequality on a number line to show all the solutions. So here you can see that you have a number line. It says a closed or shaded circle on the above graph would show the solution for x is less than or equal to 15. So if you can see, it says shading to the left represents that its number is less than, because as you go to the left, the numbers go down. It says 15 is not a solution because it says 15, x is less than 15. So since 15 is not included, we used an open circle to show that it goes up to 15 but does not include 15. If it was less than or equal to, that's where we use the closed like it says here. And then this circle would just be filled in. We can check it. You can substitute values for x to check your solution. The graph shows that negative 5 degrees Celsius is a possible solution. So we can replace x with negative 5 to check. So here you can see we have x is less than 15. When I plug in negative 5 is less than 15, so that is true. The graph shows that 16 is not a solution. You can replace x with 16 to check. So here we have our inequality. Here we plugged in 16. Is 16 less than 15? No, it is not. So you can see that it is false. So let's go through and answer some problems. Number 2, what words in the problem help you know which inequality symbol to use? Well, we can look back at our chart, but it shows that it was below 15. Okay, so that means that it has to be less than if it's below. And if we wrote that as an inequality, it would be x is less than 15, like it showed on the previous page. Number 3, look at the graph. Why is there an open circle at 15? What does it mean? Well, I kind of mentioned this earlier. An open circle on the number means that the number is not included. So 15 cannot be a solution, or cannot be x. Okay? It can go up to 14.99, but it cannot be 15. Number 4, explain the meaning of the shaded line and arrow to the left of 15. The shaded line and arrow to the left means any number less than 15 is a possible solution. This is a 15. This is a possible solution. So number 5, would the heater turn on if the temperature was 2.5 degrees Celsius? Explain how you know. Well, if we look on the number line from the previous page, 2.5 is actually to the left of 15. So yes, because 2.5 is less than 15. So it would work. So number 6 says, suppose the heater turns on when the temperature is at 15 degrees Celsius or below. Write an inequality for the situation. So this time it says is at 15 or below. So now we are including 15. So we'd still use our x. We'd still have our less than, only now we would put less than or equal to because the 15 is now included with our possible solutions. So if we graph the solution on the number line, it would still be very similar. We're still going to have our circle on the 15. Our arrow's still going to go to the left because that is less than. But now we need to fill this in. Because when we fill it in, it shows us that it includes the 15. So we would put a closed dot on. It's not very easy to do this right now. We'd have a closed dot there. So, number 7 says, explain when to use an open or closed circle when graphing an inequality. So when the number is not part of the solution, use an open circle, or one that is not filled in. When the number is part of the solution, you use a closed circle. So we would do a closed circle like that. So now I want you to try it. Use what you just learned about graphing inequalities to solve this problem. This graph shows the solution of what inequality? So the first thing I need to look at is what number am I on? So you can see I have -5 here and -4 here, and I'm in the middle of it. So what is halfway between -4 and -5? It would be -4.5. I'm going to compare it with x. I honestly think it's easier if you always put the variable first, because if you put the variable first, then all you have to do is put your sign in the direction that the arrow is going. So since our arrow is going to the right, my sign will go to the right, and then I just have to look at this. Is it open or closed? In this case, it's closed, so we use a closed circle, which means it includes. So our inequality would be x is greater than or equal to negative 4.5. So let's do some more inequalities. All right, sorry about that. So more inequalities. Cooper spent at least $25 at a music concert. What are some possible amounts of money Cooper could have spent? Write an inequality to represent the amount of money Cooper spent and graph the solution on a number line. So for the model it says you can use words and symbols to represent the problem. The amount Cooper spent, which is x, is greater than or equal to 25. Okay, it says at least. At least means greater than or equal to 25. So you can see here we wrote our inequality. Another way to think about the problem is that 25 is less than or equal to the amount Cooper spent. So basically we just switched it around. If you put your number first, your sign has to be switched as well. The second one is the model it. You can graph the inequality on a number line to solve the problem. So, since we have greater than or equal to, we have a closed circle on the 25 with an arrow to the right. The last is the check it. You can substitute values in for x to check to see if you're right. So the graph shows that $25.50 is a possible solution. So if I plug that in down here, you can see, $25.50 is greater than or equal to 25, so it would be true. We can look at 30, and we can replace the x with 30. So here we turned it around and we put the 25 first, so we switched everything backwards. So on this one, we plug in 30 for x. Once again, 25 is less than or equal to 30, so it is also true. So let's go through and answer these questions. Number 9, explain how x is greater than or equal to 25 and 25 is less than or equal to x. Both represent the same amount Cooper spent at the concert. So it shows or tells us that he spent at least $25. Okay, that is the same as being less than or equal to the amount spent. It all just depends on whether your variable's first or your variable's last, the amount that he spent. So, number 10 says, look at the graph of x is greater than or equal to 25. What does the closed circle mean at 25? Well, that means that it's included. X can be equal to 25. Number 11, what is a possible amount of money Cooper could have spent? And then check your solution. So basically we're going to pick anything that is 25 or above. So we could say, I don't know, maybe 50. So then if I plug that in, I would say 50 is greater than or equal to 25. And in this case, that is true. Number 12. How would the inequality be different if the problem said that Cooper spent more than $25? Write and graph the inequality on the number line. If he spent more than, is the 25 included this time? No, it's not. So instead of greater than or equal to, it would just be greater than 25. So then when we graph that, we would find our 25. It does not include the 25, so we leave it open with our arrow to the right. Number 13, explain how a shaded line means that fractions, decimals, and numbers not labeled on the number line can be part of the solution of an inequality. Inequalities have many solutions. The shaded line includes all numbers and numbers in between. Ran out of room. That's supposed to be in between there, including fractions and decimals. So, just because the number isn't written on the line does not mean it's included. It includes everything in between each of those numbers as well. So, now you are actually going to try this one on your own. So, we're going to use what we just talked about, and I want you to answer number 14. Take a moment, pause the video, solve it, try your best whether you understand it or not. Try to solve it, have something on your paper. Then resume it, and you can check to see what I've done and correct it if it's incorrect. Okay, so now let's look at this. It says some sources say that the Earth's atmosphere does not exist, so does not exist above 30.5 kilometers. Write an inequality to represent the atmosphere exists. Now, graph the solution on the number line below. So if it does not exist above, that means it would have to be below. So, since we know it's not above, we know it's going to be less than. And we have our x to represent the actual kilometers. So we have some number of kilometers has to be less than 30.5. But let's think about this. If it doesn't exist above it, can it exist at it? In this case, yes, it would. So it cannot go above 30.5, but it can include 30.5 kilometers. So our inequality would be x is less than or equal to 30.5. So now that we know this, we're going to graph the solution on a number line. So if we're looking at 30.5, I see 30 is here, 31 would be in between, so my circle is going to have to go in between these two lines where that is. Okay, so then the next thing I need to look at, it says that it's less than or equal to, so that means it's a closed dot with an arrow going to the left because it's less than. So, now what you need to do is get back on Classroom. You need to complete the exit ticket. And once you finish the exit ticket, I want you to go ahead and work on the the instruction workbook page 202 and 203. Work through the examples, and we will go over these tomorrow.